Today we are going to do experiment on line regulation and load regulation using Zener diode. Line regulation, it measures how well the voltage regulator maintains a constant output voltage in spite of changes in the input supply voltage. If you change the input supply voltage, how well the output voltage changes. So, and how we get the constant output voltage. So that is measured with the help of the line regulation. The formula for line regulation is change in Zener voltage divided by change in the supply voltage into 100. The circuit diagram for this is, here we have connecting low resistance 100 ohm resistance in series with power supply, and one ammeter to measure the Zener current, and DRB to vary the resistance value in the load, and 1 voltmeter across DRB to measure the voltage. So for this circuit we need 2 voltmeter, one as ammeter and one as voltmeter. So this multimeter I am making as ammeter, and this multimeter I am making it as a voltmeter. Okay. Here I am connecting 330 ohm resistor. I don't have 100 ohm resistor, that's why I am connecting 330 ohm resistor on breadboard, and one Zener diode. The black strip represents cathode and this side is anode. I have made connection like this. According to the circuit diagram, the positive terminal of the power supply should come to 330 ohm resistor. Positive terminal of the power supply should be connected to 330 ohm resistor. Other end of 330 ohm resistor to positive terminal of ammeter. This is ammeter. So it is connected to other end of resistor, and negative terminal of the ammeter to cathode. This is negative terminal. It is connected to cathode, and anode is connected to ground. This wire I am taking, I am connect this to ground. Okay, and DRB positive to the other end of resistor. This is second end of resistor. Okay, DRB negative to ground. This is DRB negative, it is connected to ground, and the negative terminal of the power supply to ground, and the negative terminal of voltmeter to ground. So this is voltmeter, negative terminal to ground, and positive terminal of the voltmeter to second end of resistor. At the second end of the resistor, positive terminal of ammeter, positive terminal of the DRB, positive terminal of the voltmeter. On the ground, negative terminal of the power supply, anode, DRB, and voltmeter negative terminal. 4 points should come on the ground. These are the 4 points. So this is about the connection. Now, since it is a 9.1 Zener diode, so we should start taking reading from 8 volts. So I will adjust this to 8 volts. Now I adjust this to 8 volts. 8 volts. So check the reading here. So let us keep the DRB at 1 kilo ohm. So I have kept at 1 kilo ohm, other all are 0. So load is fixed here. Now we will vary the power supply voltage. For 8 volts, the voltage across the Zener diode I am getting 6.04, and current through the Zener diode is 0. Let us entry this into the tabular column. So load voltage I am getting 6.04 volts, and Zener current 0.0 milliamps. Okay. Now I will adjust this to 9 volts. So for 9 volts, it is giving me 6.8 volts, and Zener current is still 0. Now I will adjust this to 10 volts. For 10 volts, it is giving 7.58, and current is still 0.0. Now I'll adjust this to 11. So it is giving me 8.31. Current is still 0. 12 volts. For 12 volts, it is giving 8.9 volts and current started to flow 0.8 milliohms. So for 12 volts power supply, it is giving me 8.91 volts. Now 13 volts, it is giving 8.999 volts and current is 3.3 milliamps. 14 volts, it is giving 9.06 and current is 6.1, and last reading will take 15 volts and voltage is 9.145 and current is 9.0 milliamps. So these many readings we have taken. Now we will calculate the line regulation. So line regulation is change in Zener voltage divided by change in power supply. What is change in Zener voltage? Zener voltage is final value is 9.1. Line and load regulation using Zener diode. We are using the components 9.1 volts Zener diode and a small current limiting resistor 100 ohm or 330 ohm resistor and a load resistor DRB and DC power supply, ammeter to measure the Zener current and voltmeter to measure the load voltage. And RPS it provides the adjustable input voltage, and the current limiting resistor 330 ohm which we have connected in the circuit, it limits the current through the Zener diode, and Zener diode is the main component which regulates the voltage at the output. And the load resistance, it is connected in parallel with the Zener diode to study the voltage stability under various load conditions and various line voltages, and ammeter to measure the Zener current, and the you can connect one extra ammeter to measure the load current also, Zener current also, and voltmeter to measure the load voltage. And for line regulation, you should keep the load constant. We have kept at 1 kilo ohm, and vary the line voltage and record the load voltage and a Zener current. For load regulation, you should keep the line voltage constant. So we are keeping at 11 volts and change the load resistance from open circuit. Open circuit means no load. You remove the load and measure the voltage, and then connect different resistance 1 kilo ohm, 2 kilo ohm, 5 kilo ohm, 10 kilo ohm, etc., and measure no load voltage and full load voltage, and then according to the formula calculate line regulation and load regulation. For this line regulation, these are the recorded values. So we should take change in Zener voltage any two consecutive readings. I am taking the last two, 9.15 and 9.06. So the change in Zener voltage is 9.15 minus 9.06. Change in supply voltage is 15 minus 14. So it is 1. 9.15 minus 9.06 is 0.09. 0.09 divided by 1 into 100 is 9%. So the line regulation is 9%. Similarly for line regulation, it is always expressed in percentage. So lower the percentage, it indicates better voltage regulation. So now we are going to do for load regulation. Load regulation means we should keep the input voltage constant and we should vary the load resistance. It measures how well the voltage regulator maintains the constant output voltage despite changes in the load resistance, and it is calculated by no load minus full load divided by full load into 100. Now I'll keep the RPS voltage to 11 volts and we'll start varying the load resistance, and we will write the readings in this tabular column. So I am keeping the line voltage 11 volts, and first reading I will take no load. No load means you should remove the load from the circuit. So I will remove the load. So the voltage across the Zener diode is 9.03. That I will mark as no load voltage. So no load voltage, I am writing it as 9.08 volts. Now I will connect the load. Initial value I am keeping 1 kilo ohm, and the value of the load voltage is 9.09 and current is 5.8 milliamps. For 1 kilo ohm it is giving 9.07 volts, and for no load voltage it is 9.08 volts. Okay, now I'll increase the resistance to 2 kilo ohm. I'll increase this to 2 kilo ohm and note down the reading. It is 9.07 volts. 9.07 volts. Now I'll increase the voltage to 5 kilo ohm. 5 kilo ohm, and the voltage across the load is 9.07 only. 9.07 volts for 5 kilo ohm, and I'll increase this to 10 kilo ohm now. 9, 10 kilo ohm, and the voltage across the load is 9.07 volts. 9.07 volts. Now for load regulation, these are my values. When a load is removed from the circuit, I got the voltage across Zener diode is 9.08 volts. And when we start taking readings from 1 kilo ohm, 2 kilo ohm, 5 kilo, 10 kilo ohm, the full load voltage is 9.07 volts constant. So no load voltage is 9.08. Full load is 9.07 only. 9.08 minus load regulation is calculated using this formula. No load voltage minus full load voltage divided by full load voltage into 100. No load voltage is 9.08 minus 9.07 divided by full load voltage is 9.07 into 100. So the difference is 0.01 divided by 9.07 into 100. It is 0.0011 into 100, 11%. For line regulation or load regulation, the regulation is expressed in percentage. So lower the percentage, it indicates better voltage stability under different load condition for load regulation.